Everybody, welcome back. In this video, we're going to continue our discussion of assembly language programming, and in this video particularly, we're going to talk about implementing while loops and for loops. I assume that you've got a lot of experience or some experience in the programming language C, so I'll be referencing that language a little bit in this video. So this will probably be a review right here, this slide anyway. A while loop, let's talk about it. While loop's a block of statements that continuously executes so long as a Boolean statement is true. A Boolean statement is a conditional statement that evaluates to true or false. So as long as that statement is true, we're going to execute our block of statements. And in assembly language, this is going to be implemented using test, compare, and conditional jump instructions. And then if you know the C programming language, you know that the Boolean statement is inserted within parentheses of a while keyword, and then the block of statements is inserted within the curly brackets. All right, so let's look at an example. This is assembly language here, and then at the end of this example, I'll show you what the C code looks like. So you'll notice if you're looking at this while loop example, you'll notice two different while loops, while C, while UC. The C stands for conditional and the UC stands for unconditional. So as we go through this, keep that in mind that the first one, the top one there, is a conditional while loop. And then the second one, the bottom one, is an unconditional while loop. So at the very beginning of this, we're allocating space and memory, and we're going to have var point to the address that is storing the number 3 initially. All right, now when we execute the program proper, we're going to compare the number 3 with what var is pointing to, which is 3, of course. So when we make that comparison, the 0 flag gets set to 1. And why is that again? That's because in order to do the comparison, it takes the difference of those two numbers. So 3 minus 3 is 0. The 0 flag goes up. We got z equals 1. And so when we get to this jump if not 0 instruction, we do not jump, again, because z equals 1. That's a jump if not 0. So the program counter marches along, and then we move the number 1 into that address labeled var. So now var is pointing to the number 1, and then we have a unconditional jump back up to the top of the while loop. So if you're using CCS to do this, you can step into the program and watch the PC decrease when this happens. All right, so now var is pointing to 1, so we compare the number 3 with the number 1. And here the 0 flag is cleared now because it does the subtraction and we do not get 0. And so then we go to jump if not 0. And so because z equals 0, we do the jump and then we end that while loop there. So in C code, that would look like this, and it's trivial. This is for educational purposes. This is not anything earth-shattering. Okay, you might be looking at that C code and be like, I would never type that ever. Probably not. But anyway, it illustrates the example hopefully for you. So you'll see in the C code we're using the var, the variable var, as the comparison. We're comparing it against the 3. And then inside the while loop, then we set var equal to 1. So it really only executes one time before exiting. Okay, now the second while loop is an unconditional while loop. So let's check this out. So here we're going to move the number 2 into that space in memory. So now var is pointing to the number 2. And then we're going to just unconditionally jump back up. That's it. And again, if you're using CCS, you can step this, you can watch the PC decrease, but that's it. That's our earth-shattering piece of code here. And if you know C code, then you'll know that this is a while, this is an always or an infinite while loop, while 1, and then inside there we're going to set the variable equal to 2, and that's going to go on forever. That's it. Okay, so again, the example, the point of this example is not to do anything earth-shattering here. It's now we're trying to like bridge assembly to C, and we start at the basics, right? So we're trying to make that comparison. Given some assembly code, what would it look like in C code? Nice. All right, now let's look at a for loop example. So initially, we're going to store the number 0 into register R4, let's say. Okay, nice. Now we're going to move R4's contents into program memory. So now that's in the block of memory that we allocated, and so the label var is pointing to the number 2 in space. Okay, now let's increment the value stored in R4. So it was 0, now it becomes 1. And let's do a comparison against, let's say, the number 4. So because R4 is storing 1, this comparison is not true, or the 0 flag is cleared, said another way. Right, so the 0 flag is cleared because it does the comparison, it does the subtraction. 4 and 1, you don't get 0, so z equals 0. Then we jump if not 0, so we jump in this case back up to the for loop. Watch the PC counter decrease if you're doing this in CCS. Now let's say we move R4's contents, which is currently 1, into program memory, right? And we keep doing this. So it was 0, and we tested it against 4, and then so we loop back up. Now we incremented it to 1. We store 1 in memory. We test that against 4. We keep doing that until the number 3 is moved into address. So this is key now. Is it going to be 3 or is it going to be 4 in R4 and in memory, right? So let's try to iron out those details. So when the number 3 is moved into the address labeled by var, okay, R4 stores the number 3, then R4 is actually incremented to 4 from that instruction there. Because that's what's going to get us out of the for loop. We're going to compare now the number 4 with 4, and the 0 flag is now set, right? Z equals 1. And here, there's no jump. Jump if not 0, since z equals 1, and so there's no jump back up to the for loop, and so the PC, the program counter, keeps marching right along, and that's the end of the program, right? So here's a subtle point that I want you to notice. After the execution, register R4 contains 4, right? You can verify that by looking at our notes that we just went through. But var contains the number 3. So you think now, like, what would that code look like in C? Here's what it would look like in C. For I equals 0, I less than 4, and I plus plus. Var equals 1. Or var equals I, excuse me. So what this is going to do is it's going to start at I equals 0, set var equal to 0, then increment by 1, I equals 1, set var equal to 1, increment to 2, var equals 2, increment to 3, var equals 3, and then if I were to become 4, then this thing kicks out. So var is equal to 3 when this loop is done, but there has to be that test against 4 to know, for the computer to know that it's going out of the loop. And so that's what the register was storing. I'll back up a second. Let me back up a slide there. Again, in red there, register R4 contains 4, but var contains 3. Nice. All right, so that was the while and the for loop. And next time we are going to look at implementing the if-else statement, and I say case statement there, but switch and case statement. Okay, as always, thank you very much, and I'll see you next time.